Okay, now we're looking at the fourth type of area and volume problem, the good old area and volume. Now you think that you have this mastered. I know you do, but I'm going to throw some tricks your way. Okay, first of all, when you are doing these problems, a couple of things you need to keep in mind. Did you know that this type of problem has appeared every single year since 1969 in the AB exam? So you better be solid on it. Don't skip this one. Now, they are starting to include these types of questions in the non-calculator section more frequently because there are programs that can find disk and washer method on calculators. Now, as a result then, they kind of have to vary it up. So they're not quite as straightforward we've been seeing in the past couple of years as they used to be. Now, do not give up on these problems. Get your partial points. Don't be thrown by it. So I'm going to show you a few little twists on them to make sure that you feel prepared. But before we do that, a couple of things you need to be able to do. If you are given two functions, you will need to find the intersections of those functions if it's a graphing calculator question. Remember for these, you graph the functions, and then you're going to analyze graph, and you're going to go to intersection. Do not do the trace button. We found that the trace button sometimes is not as accurate as using the analyze graph technique. Also, be familiar with the disk and washer method. Review those two. Do a couple of examples. And then you probably will need to be able to find a cross-section of a region. You need to know the square formula, which of course is just the length, upper minus lower, squared. Semicircle. Be careful with that, because remember it's half of a circle. So we know that a circle is pi r squared, but then you're going to have to take half of that because it's a semicircle. And normally, when you take the length of the upper minus lower function, you are given the diameter. So typically, you're going to have to take that length and divide by 2. So there's a lot of dividing by 2 going on. Right isosceles triangle, don't be thrown by that. That's usually just 1/2 base times height. And your base and your height, since it's isosceles, is just going to be the length of the upper minus lower function squared. And the equilateral triangle, do you remember what that is? Remember, it's radical 3 over 4 side squared. Okay, so you've got those formulas. And the last type of twist we've seen recently is that you have to find the equation of a vertical line that divides the region in half. So you'd set 1/2 of the region equal to the total value of the area of the region. One calculator tip I wanted to give you is that when you're doing these problems, if it's a calculator, make sure you always show the setup. So, if you're doing some type of semicircle, you're going to go pi, and then you're going to do the radius, which usually is some length, divided by 2 squared in respect to x. So make sure you show your setup, and then plug it into the calculator, and then get your answer. And of course, always, we're going to do a minimum of 3 decimal places. Okay, now do not take the antiderivative by hand if it's calculator, because if you make a mistake, you will lose points. Okay, here's our first example. Now this is an example of a calculator allowed problem, and you see that you've got your 2 functions given to you. So first thing I would do is put this in f of 1 and put this into f of 2 and label them so you remember which is which. And now would you answer A through D? Do not leave any blank. Do it in pencil, and then you'll do your corrections in pen. Now, as you can see, I threw you a few twists on this problem. Here, let me make sure I've got my rubric up here at the computer. And so when you look at part A, you were asked for the area. Well, that wasn't too bad. So you would just want the upper function minus the lower function from 0 to 2. So you get 1 point if your limits are right, 0 to 2. 1 point if the integrand is right. Make sure you remembered your in respect to x. And then the third point for the answer of 4. Nice. Okay, in part B, you're asked to divide it with the y equals -2. So you've got some crazy kind of curve going on here. Now I know this isn't quite exactly it. And you've got y equals -2 right there. So you had to find these 2 intersection points using your calculator. So those 2 points where it intersected was 0.5391889 and 1.6751309. Okay, and now you're just going to find area. So you're going to go upper minus lower using those intersections. So did you get the right limits? Those would be the intersection points. And was your integrand set up correctly? Upper minus lower. Okay, For C, you are asked to find cross sections with squares, and we know that a square is just the length squared. So you went upper minus lower, and you squared it from 0 to 2. Nice. And then for the last one, you're told that you have a surface of a small pond. Okay, you've got your pond going on here, and then you are told the depth. So to find volume, we take the surface area multiplied by the depth. Well, we've already found the surface area. It's the upper minus the lower function times dx, okay? So that's the area of the surface, and then we have to multiply it by the depth. So you can see those are your 3 dimensions there for volume. We've got the depth, we've got the basically the length of the pond, and then times the width. And so you set that up correctly, and then you get your answer. So on this one, what was your score on this FRQ? Be ruthless. How'd you do? And then reflect on your weaknesses or mistakes. What did you learn from this? What mistakes did you make? Okay, here's the second example of a no calculator. So these are the ones we've been seeing more frequently, and they're going to throw you maybe a little twist. So do not give up on these. Persevere, push through them, okay? Even though it looks a little different. So in this example, you're given a funnel. Now notice we are given the equation for the radius is 1 over 23 plus h squared. And you're given the limits from 0 to 10. Show work for all parts A, B, and C. I want something written in pencil. Do something. Don't leave anything blank. And then we'll correct it together. Okay, now make sure you do your corrections in pen so you can see what you learned from this, what you knew and what you didn't know. So the first question is the average value. Well, we know we do average value by taking the integral over the interval. So the integral is from 0 to 10 of the radius divided by 10. Now notice this is no calculator, so you needed to do this by hand. So you needed to take the antiderivative. Okay, so the antiderivative is 3h, the antiderivative of h squared is h cubed over 3, and you're evaluating it from 0 to 10. So the integral, 1 point, the antiderivative, 1 point, the answer, 1 point. Do not lose those 3 points. Those were probably the simplest ones. Now in B, you have to find the volume of this funnel. Now that looks a little tricky, but hopefully you realize, whoops, sorry about that. Hopefully you realize that really what this is a disk method problem. So you've got this funnel, and mine's drawn really bad, okay? And what you're gonna do is you're gonna revolve it around this center line here. So when I draw my representative rectangle and I'm revolving it, we see it's the disk method. And so this is going to be pi, and then the integral of something, r squared, okay, dh. So the radius then would be your formula 1 over 23 plus h squared, and you're going from 0 to 10. So again, you have to do this by hand, and so if you take out the 1 over 20 and it's squared, so it's actually 1 over 400, you get pi over 400, and you're going to integrate 3 plus h squared squared, so you have to square that and then take the antiderivative and evaluate it from 10 to 0. So this is the integrand, antiderivative, and the answer. Now the last question. They threw in a related rates for you here. I'm sure you love that. But don't be discouraged. You can do this. So you're given the function r, and you're told that that is 1 over 20, quantity, 3 plus h squared. And then you're given 2 conditions. You're given that the instant when the height is 3, so this is my first condition, height is 3, you are told that the decreasing rate, the surface area, is decreasing. So the rate is negative 1/5 inch per second. Sorry, I was trying to look at the answer at the same time. Inch per second. And that is the decreasing rate of the radius. So dr dt. You can do this. So first thing you do is take the derivative of this in respect to time. So take the derivative of r in respect to time. And then we get 1 over 20. Now the derivative of 3 plus h squared is 2h, but don't forget your implicit differentiation. It's a derivative of h in respect to time. Notice if you do that, you get 2 points. You can do that. Now plug in the values of 3 and negative 1/5, and then you get your answer, negative 2/3 inch per second. So this was a tough problem. In fact, this was from last year, 2016. So how did you do on this problem? What was your score? and then reflect on your weaknesses and your mistakes. Learn from this problem so that if you see one again this year, you'll nail it.